Hello everyone, welcome back to Diksha Vedantu Foundation channel, and today is Sunday, so today is the time for the mock test. So day 54 of 99% in 99 days. I hope you have prepared for this mock test. I already told you yesterday that this week's mock test will be based on the chapter magnetic effect of electric current. We have only completed one chapter this week because of the holidays, so we will be taking our mock test on this chapter only. Okay, so let's start with the question paper. I hope you enjoyed the question paper. Solving the question paper, we have as usual 6 MCQs, then we have 4 marks questions based on 2 markers. So 2 marker question, 2 3 marker question, and 1 long answer type question, 1 case based question. Okay, this is generally our pattern for this chapter, but this is a small chapter, and in terms of importance, in terms of previous year questions, the weightage from this chapter is very low, as electricity is a major chapter in this section. So if you know your question pattern, there are basically 2 sections. One is natural phenomena, which includes light and human eye chapter. In that chapter, light is the major chapter, strong chapter, and human eye chapter is a slightly lighter chapter. Similarly, in this section of the electricity part, where electricity is the major chapter and magnetic effect of electric current is a smaller chapter. This chapter becomes huge when you go to your class 12th. Okay, in the class 12, the same chapter you will study again, and then you will study a lot about all the other phenomena in mathematical treatment, etc. So this is just a beginning, this is just an introduction of this chapter, right? So let's start with the question paper. First question: the magnetic field inside a long straight current carrying solenoid is 0, decrease as we move towards its end, increases as we move towards its end, it is same at all point, it is same at all point. Next question: assertion reason based question. A current carrying straight conductor experiences a force when placed perpendicular to the direction of magnetic field. The net charge on a current carrying conductor is always 0. Now, if you see, both assertion and reason are actually correct. We discussed it in our previous year question discussion, but there is no direct relationship between assertion and reason. So both assertion and reason are correct, but reason is not the correct explanation of the assertion, right? Next question: choose the correct statement from the following regarding the magnetic field lines of field. Okay, so regarding the magnetic lines of field, which of the following statement is incorrect? Very important. So there are 3 correct statement, only 1 incorrect statement. So we have to identify which is the incorrect statement. Let's read the question. The direction of magnetic field at a point is taken to be the direction in which the north pole of a magnetic compass needle points. Yes, this is a correct statement about magnetic field. The magnetic field lines are closed curves. Actually, this is also correct statement. If the magnetic field lines are parallel and equidistant, they represent 0 field strength. Actually, it is not. Even the magnetic field lines are parallel and they are equidistant, that represents the magnetic field strength is constant. It is throughout the area, throughout the region, magnetic field strength is constant, not 0. So this is an incorrect statement. Obviously, I can see, you can check the option D as well. Relative strength of magnetic field lines is shown by the degree of closeness of the field lines. So more close are the field lines, the stronger is the magnetic field. So this is also a correct statement. So only incorrect statement is option C. Very important. So parallel field means field lines parallel. If the field lines are parallel, that means the field is constant. We see that in case of for example, circular coil, in at the center the field lines are almost parallel to each other and equidistant. So that represents a constant magnetic field, not 0 magnetic field. Now question number 4: if the key in the arrangement is inserted, the circuit is made closed. So now what we have done, so initially suppose the key was open, now you have closed the circuit so that current is flowing in the circuit. Okay, the magnetic field lines are drawn over the horizontal plane ABCD. The lines are, so what will happen, the current is flowing in the circuit in this direction, so the field lines will be, so we know we have to apply right hand thumb rule. You have to put your thumb in the direction of electric field, and if you curve your finger around it, then that curve will represent the direction of magnetic field. So in this case, as we know, in case of current carrying wire, the magnetic field lines will be concentric circles and the direction will be in this direction, right, from A, B, C, D, A, B, C, D, A, this loop, right. So, it will be concentric circle, the magnetic field lines will be concentric circles. So, correct answer is option A. Now, question number 5, the most important safety method used for protecting home appliances from short circuiting or overloading is obviously use of fuse. So, fuse is a device which is mandatory for all the costly equipments, so that our devices stay protected from overloading or short circuiting. There are two different mechanisms. One of the students asked what is the difference between short circuiting and overloading. Short circuiting happens when positive and negative are connected together and huge amount of current flows without absence of any resistance, that may cause the circuit to burn, that is called short circuiting. Overloading is on the other hand is when a huge amount of current flows in the circuit. That huge amount of current flowing in the circuit does not necessarily to be due to short circuiting. Short circuiting is one of the causes due to which overloading may happen, but overloading can happen due to, suppose somehow high amount of voltage is supplied by the supplier, that is one of the causes, or suppose your building is not earth and there is a lightning strike your house. Okay, in that case because of the high voltage of the lightning, there may be overloading of the circuit that may happen in your home, and your TVs, fridge, refrigerators, etc. might get burned. It used to happen in the past. Nowadays we are more careful with lightning rods, grounding, and fuses and MCBs, they are now installed. So, that is why overloading due to these conditions are reduced, but still may happen. Okay, but short circuiting is also one of the reason of overloading. So, I hope that clarifies whoever else has this same doubt. Now, next question, the strength of magnetic field inside a long current carrying straight solenoid is more at the ends than at the center, is minimum at the middle, same at all points. It is obviously same at all points, found to increase on the one end to other. No, this is not like that, and this is actually the same question on the first question, just a language is changed, but this is almost the same question as first question, right. So, because as I said number of questions possible from this chapter are very less, not too much questions are being asked from this chapter. So, I had no other option, but this question is actually from one of your previous year. So, that is why I have just recycled one question. Now, let us look into the 2 marker short answer type questions. A magnetic compass shows a deflection when placed near a current carrying wire. How will the deflection of the compass gets affected if the current in the wire is increased? Support your answer with reason. So, first of all, a magnetic compass shows a deflection when placed near a current carrying wire. So, suppose there is a current carrying wire, you have a magnetic needle. Magnetic needle is a small device, okay, which shows north and south. Okay, there are generally north side is painted with red color and south is painted with white color. So, by seeing the magnetic needle, red color means it is a north pole. So, basically whenever you see that, okay, this is the north direction, that means this is the north direction. So, as soon as you start the current in the circuit, what happens is that this magnetic needle, it deflects at some direction, not random direction. You can actually find which direction it will deflect. Now, what will happen if you increase the current in the circuit? If you increase the current in the circuit, the magnetic needle will deflect by more degree, right. So, why it so? When the current in the wire increase, the deflection of the magnetic compass will definitely increase. So, suppose initially the deflection was, suppose this is initially at rest, this is the direction. Now, after the current started, this is the initial deflection, say theta, and if you increase the current the angle will be increased. So, now this is phi. So, phi is definitely more than theta. Okay, suppose initially the deflection was 30 degrees. Now, if you increase the current, it will increase from 30 degrees to say 45 degrees. Okay, so the angle will change. So, deflection will be more. Now, why it is so? The current carrying wire generates a magnetic field B around it with the strength of the magnetic field B directly proportional to the current I in the wire. So, magnetic field here, suppose the magnetic field, initial magnetic field is B. We know that a current carrying wire produces magnetic field, right? That is already established fact that a current carrying wire produces magnetic field. Now, the magnetic field it has a strength, right? The strength of the magnetic field, say B. Now, this magnetic field strength is directly proportional to the current flowing in the circuit. B is proportional to I. So, as you increase the current, B will increase, more B means more deflection. That is it, simple. Now, next question, state two important advantage of using alternating current over direct current. Very easy question. It is more efficient for long distance transmission. AC system can be used transformers to easily step up or step down voltage level. So, you can change the voltage level, you can transmit it for a long distance. That is why AC is more convenient than DC. I have also given you some examples. Yesterday's class also I said that AC devices are more common. Almost all devices work on AC, and it is easy to convert AC to DC. Okay, whereas it is difficult to convert from DC to AC. Now, what does the direction of thumb indicate in the right hand thumb rule? In what way this rule is different from Fleming's left hand rule? This is a 3-mark question. So, slightly longer answer. The direction of thumb in the right hand thumb rule indicates the direction of the current in a straight current carrying conductor. Simple. So, we know that if there is a current carrying conductor, you have to point the thumb in the direction of the current. So, thumb represents the direction of current. In the right hand thumb rule deals with the relationship between current and the magnetic field. So, right hand thumb rule talks about that if there is a current, there will be a magnetic field, right. So, this is the simple as that, but Fleming's left hand rule explains the force on a conductor in a magnetic field. Force on a not only a conductor, it will be a force on a current carrying conductor. Right, force on a current carrying conductor you can find using Fleming's left hand rule. So, only a current carrying conductor is there, you can apply right hand thumb rule. There is a current carrying conductor as well as a magnetic field, and you want to calculate the force on the conductor, then you apply Fleming's left hand rule. Okay, as simple as that. Now, next question, why is an alternating current AC considered to be advantageous over direct current DC for the long distance transmission of the electric power? Very common question. It is more efficient in long distance transmission. AC systems can use transformer to easily step up or step down the voltage level. So, higher the voltage level, easier to transfer and less power is consumed. So, less power wastage is less. That is why AC is preferred over DC. Second, how is the type of current used in household supply different from the one given by battery or dry cells? Okay, the household supply provides alternating current AC, whereas the direction of current changes periodically, typically 50 Hz. Battery of dry cells provide a direct current DC, where the current flows in a single constant direction. So, that has also explained that AC means it is changing direction every oscillation. 50 Hz means 50 oscillation in 1 second, whereas the DC is just a straight line. This is a DC, this is AC. If you draw this graph, it will be very helpful. Now, next question, draw an appropriate schematic diagram showing common domestic circuit and discuss the importance of fuse. Why is it that a burnt out fuse should not be replaced by another fuse of identical rating? This is very important. So, let us see the circuit diagram. So, you have to draw this circuit diagram, a simplified version of it. So, here the plug points are there, you can add fan, TV, fridge, etc. So, everything is connected in parallel combination. Okay, here is electricity board fuse, there is electricity meter, there is a distribution box containing main switch and fuses of each circuit. So, this is a fuse circuit for all the circuits, and from here you are getting two circuits. This is live wire, as you can see, red is live wire, black is neutral wire. This is the earth wire. Earth wire is done by your side, your home, it is connected to your home, whereas this live wire and neutral wire coming from the electric supply. So, there is a fuse given by the electric supply commission as well, but that is a high rated fuse, they do not fuse easily. So, that is why you have to use fuse for individual circuits as well. So, you can see there are 1, 2, 3 fuses, 1, 2, 3 circuits in the home, right. This is the very easy circuit, and it is a parallel combination. You have to practice this circuit at least once. Okay. Now, When too much current flows through the circuit, the fuse wire melts or blows, breaking the circuit and stopping the flow of the current. Thus, it helps to protect appliances, wires and humans from excessive current. Right, fuse is rated to allow only a specific maximum current. For example, if the fuse's rating is 5 ampere, it will blow if the current exceeds 5 ampere, thereby protecting the circuit. So, there are some devices which require 5 ampere current. Okay, if it is more than 5 ampere, they may get burned. Okay, for example, refrigerator, modern refrigerators, they operate under 5 ampere. Anything more than 5 ampere, that might burn the circuit, right. So, 5 ampere is the required voltage for refrigerator. If a fuse with a higher rating, that is for example 10 ampere is used, it may blow, it may not blow even when the circuit carries a dangerous current. This can cause overheating, appliance damage or fire. So, suppose you have a 5 ampere device, okay, and you have connected a 10 ampere fuse. Now, current in the circuit somehow increased to 8 ampere. That 8 ampere is not recommended for that device. So, what will happen in that case is your circuit will your device will still function even if the current goes to 8 ampere. Fuse will not blow, because maximum limit is 10 ampere, you have fixed the fuse to be 10 ampere, but maximum limit of the circuit is 5 ampere. Circuit will overheat, and due to overheat there may be cause of fire. Okay, the device may get damaged, there may be fire. So, you may have heard there are fire incidents in big industries. Okay, that this is one of the reasons that industries, if the industry they are not using proper fuses, there may be a fire. Okay, there may be some accidents. What else? If a fuse with a lower rating, that is example 3 ampere is used, it may blow unnecessarily even under normal operating conditions, causing inconvenience. So, suppose the maximum limit was 5 ampere, right. Now, you have fixed a 3 ampere fuse. You thinking that okay, 3 ampere mein to it will work perfectly. It will work perfectly, but the device can function up to 5 ampere, right. So, even if the current goes to 4 ampere, okay, the fuse will blow. So, every time you have to change the fuse, right. Even if the current goes slightly up, you have to change the fuse. So, that is also not required, because the circuit can handle up to 5 ampere. So, that is why when a fuse is blown, you have to fix the same rating fuse. That is very important. Okay, you cannot apply fuse more than the rating or below the rating. So, that is why it is very important to use the identical rating. Okay, clear? Now, next question. A student fixes sheet with white paper on a drawing board. He places a bar magnet at the center of it. He sprinkles some iron filings uniformly around the bar magnet. Then he taps on the board gently and observe the iron filing arrange themselves on a particular pattern. So, you have a sheet of paper, you put a magnet here and some iron filings. Okay, after you put the iron filings, you tap on the board, then what will happen? The iron filings will arrange something like this. You will see something like this. Some interesting pattern you will see. Okay. So, now the question is why do the iron filings arrange in a pattern? Why do the iron filings arrange in a pattern? Because of the magnetic field of the, this is due to the magnetic field of the bar magnet. Field of the bar magnet, right. What is the question B? What do the lines along which the iron filings align represent? So, what is the representation of these lines? They represent the magnetic field lines due to the magnet, right. Now, what else? What does the crowding of the iron filings at the end of the magnet indicate? So, if you see them, all the magnetic field lines, they are somewhat crowded at the end of the magnet, right. So, they are almost very much crowded. So, what is the representation of this? So, magnetic field here is very strong. So, it represents strong magnetic field, right. We know that they crowd at the strong magnetic field. If the magnetic field is strong, they crowd, and if the magnetic field is weak, they do not crowd, right. So, it represents strong magnetic field. Now, what else? So, there is a OR question for the last option, how the strength of the magnetic field is indicated. So, strength of the magnetic field, same question. So, but in a different order. So, strength of the magnetic field is indicated by closeness of the magnetic field line. So, closeness of the magnetic field lines. Closer they are, stronger is the magnetic field, further they are, weaker is the magnetic field, as simple as that, right. So, we have completed today's lecture, today's test, and let me know how well you have performed in this mock test. And if you want to perform well in your future, then definitely you have to attempt our specifically designed future proof test is Diksha Scholastic Aptitude Test, where you will be very clear about your future. If you are currently studying in class 10th and you want to know what should be my end goal is, what is my strength, what is my weakness, then definitely you have to fill this form first. Okay, after filling of this form, our representative will contact you, and what you have to do, you have to once you have the registration, you can attend a 60-minute lecture. Okay, 60 minutes during the lecture there will be also doubt clarification. So, whatever doubts you might have during the lecture, once the lecture is over, based on that lecture there will be aptitude test, and based on the result of the aptitude test there will be one-on-one counselor who will guide you that what is best for you. Maybe you are thinking I am worthless, but after attempting this the counselor will tell you, you will perform well if you choose to become a doctor in future. That is, you have to prepare for NEET exam in future, or if you choose to become an engineer in future, so you have to either attempt JEE or KCET. So, they will guide you that what is best for you. Okay, maybe science is not for you, maybe commerce is good for you. So, everything the counselor will guide you, right. So, do not wait, fill up this form today and register for DSAT. Okay, I will be back with a new video. Till then, by Monday Jasmine ma'am will come, but I will be also back with some surprise video. My syllabus for this class 10th is over, but there will be more classes going on. We will continue the session. Till then, bye.